right, so set theory, okay? Lots of vocab here. So I'm just going to start you off with what is a set, okay? A set is a collection of elements, which are typically numbers. Okay, our elements are typically numbers. So when we talk about a matrix, okay, we kind of said element sometimes, okay? Kind of same thing. It's just a number, okay? But it's a collection of elements. So for an example of a set, okay, we have a group of numbers. It's in those curly brackets. Okay, just do your best to write the curly brackets. And it can really, I mean, it can be anything. Okay, it could be longer. It could be shorter than 3 numbers. There's not like a huge limit to how big a set can be. Okay, and then we have something called a universal set. Okay, the universal set is a set with all possible elements. So this will be situational. So when we're talking about a specific situation, a specific problem, there'll be a universal set. Okay, and then so say our universal set's here. We would say U equals. That would be our universal set. Okay, this is a lot of writing, so I'll give you your time here. Okay, then if we have a universal set, we have a subset. Okay, a set with all elements from an original set. Okay, so that subset doesn't have every element of the universal set, but it'll have some elements of the universal set. So we kind of have our universal set. Under that, we have the subset, which is some elements from the universal set. Okay, then we have something called the complement. Okay, the complement is the set with all elements from the universal set that are not in the subset. So it's kind of like the leftover numbers. Okay, so universal subset, whatever's not in the subset will be the complement. One thing I want you to note, okay, is the subset is written as A right here, okay? And then the complement, we don't usually use the A with the bar on top. Usually we say A prime, okay? And that's the complement. That's what was just a little asterisk, okay? So we typically say A prime for the complement. So you have universal set, subset is in the universal set. Whatever's not in the subset will be the complement. Okay, questions for me so far? No, it's lots of writing. It'll let up here just in a minute. Okay, let's move on here. So let's talk about relationship of sets. Okay, we have something called an intersection. Okay, an intersection is where we take two sets, okay, and we talk about what they have in common. Okay, take two sets and we write down what they have in common. That will be an intersection. And there's two types of intersections. Okay, so an intersection. Think of intersection as and. Okay, when you see an intersection, it's going to have the word and in it. Okay, and our symbol is kind of like an N without a stick, okay, or an upside down U. That symbol represents the word and. Okay, so by definition, an intersection is two sets and what they have in common. If we look at our sets C and D, okay, C and D, what's our intersection? What's in common between both of those? 7. 7 is in both sets. So C and D, or the C and then the symbol D, okay, their intersection is at 7. They both have a 7 in their set. Right, that's an intersection. And then our second here relationship is called a union. Okay, a union is a set containing all elements from both. So you kind of just mesh them. You take two sets, you put them together. Okay, we call this union OR. Okay, and it looks like a U without a stick, or maybe a capsule. Okay, so U is OR, and then the N, okay, the one that's upside down, that's AND. And I'm going to show you a way to remember them. If you look at AND, okay, this is, I look at it as an N. It looks like an N. Okay, so if you look at the word and has an N in it. That's how you remember this, okay? Or doesn't have a U, okay? Doesn't have an N. So and has an N. That's how I remember that. Okay? Hopefully that will help you a little bit. All right. So for the union, okay, the union is where you take both and you put them together, but you don't repeat anything. So since both C and D have 7, we only write 7 one time. We write it one time, and then we'll take 8 and 11. So we basically take both, put them together. That's the union of C or D. Okay, questions so far? All right. So now, okay, we're gonna kind of bring all this together and put it into action. Okay, we have a large bag that holds marbles of the following colors: blue, green, orange, and pink. So I'm just gonna go ahead and write down the first letter of each of those. Okay, blue, green, orange, and pink. So I'm just gonna write down the first letter of each color. A small bag holds marbles of the following colors: red, green, yellow, and orange. So we're going to write those down: red, green, yellow, and orange. So when we want to make a universal set is the set of everything that we're dealing with. Okay? Doesn't matter if one's in a large bag or a small bag, it's everything. Kind of like a union in a way. Okay? So, do we have any repeats up here? What do we have a repeat of? Yes, G. Okay, so we're going to cross off one of those, and what else? Orange. Oh, so we're going to cross off one of those. Okay, now we can make our universal set. So we just take each of those letters and put them in a universal set, kind of like a union. All right, now if we want to define a subset, so by definition, a subset is in the universal set. Okay, in this case, we have two subsets because we were given two types of information. In the large bag, okay, we had blue, green, orange, and pink. So those letters go in the large subset. And then the small bag, okay, or small subset, had red, green, yellow, and orange. So we put those in the small. So here we have two subsets of that universal set. Okay, sometimes we'll write them as lists, like we just did. Sometimes we'll put them in a Venn diagram. So for a Venn diagram, okay, if you guys have used a Venn diagram before, yes? Okay. The intersection is on the inside. What both of the sets contain. What do both sets contain? G and O. So we're going to put G and O in the inside because both sets contain a green and an orange. Then you want to look at the large. Okay, we already have green and orange. Those are done. But blue and pink, so B and G, go Falcons. All right, B and G go in that large subset. And did I miss any?
Wait, where did we?
Oh, B and, darn it, I don't think it's go Falcons. That's right. P. Okay, B and P. All right, and then in our small subset, we already have G and O. So we need R and Y. Okay, so it's just another way of showing the set. Just kind of visual. Okay, so let's talk intersection and union. So intersection is which symbol? Is it the N or the U? N. Okay, and. Intersection is and. So we're going to do we're going to do L and S. So large and small. So intersection is where they're in common. What they have in common. What do they have in common? G and O. Okay. Now, the union. Okay, the union. That'll be L or S. What's the union going to be the same thing as? You already have it out. Yeah, the universal set. Okay, where we take both of them and we put them together with no repeats. So this should match the universal set. Okay, any questions for me? All right, let's deal with some numbers here. Okay, most of the time we're going to be dealing with numbers and not letters. That was just a letter. Suppose a universal set consists of all single-digit positive whole numbers. Okay, the universal set. So we're going to say U equals. Okay, so what do I start at? If I'm talking single-digit positive whole numbers, what do I start at? Single digit. Is 0 a single digit? Is it positive? 0. Okay. 0, 1, 2, all the way up to, how did I do 8? 3, 4. Okay, do I stop at 9? Yeah, because 10 has 2 digits, right? So we're going from 0 to 9. Okay, now, in part 8, it says find E prime and O prime, okay? Or we're talking the complements. So first we have to know what are the subsets. Okay, so we're going to write the even subset and the odd subset. Is O odd or is it even? We'll call it even. Okay, for the sake of how the pattern goes, we'll call it even. Okay, what's a complement? When we're writing a complement of a subset, what are we looking for? We're going to write E prime. What are we looking for? So complement. Okay, set of all elements from the universal set, but not included in the subset. So if you have a subset, everything that's in the universal set that's not in the subset. So it's what we're missing. Okay, so here, if we look at E, what are we missing? All the odds. Okay, so we're going to write 1, 3, 5, 6, 9. So it's kind of like, in this case, it's kind of the opposite. Okay, it's kind of switching even and odd anyway. So then our odd complement will be all of our even numbers. Oh, I missed it. Part 6 was these guys. Okay, if you want to just draw in there, you can draw in there. All right, or find the intersection of E and O, and the intersection of, or I'm sorry, and the union of E and O. So we talk intersection. Okay, intersection's what? What they have in common. Do they have anything in common? Are there any numbers in common?
No.
No. So when there's no numbers in common, when this happens, we call it the empty set. The empty set is a 0 with a line through it. Okay, that's called the empty set. So that lets me know there's no numbers in common. They don't share anything. Okay, now the union, what do we do for the union? What do we do for the union? Universal set, you put them all together. Okay, it's the same thing as the universal set. Right? For a Venn diagram, are we going to have anything on the inside? No, because we don't have an intersection. That was a 0, or that was an empty set. So there's no intersection on those. All right, go ahead and start working on the practice. Okay, there's only 2 questions. I'm going to give you the answers here in a little bit. I'll give you about 15-ish minutes, okay? And then I'll give you the answers.
I did pass.
I'm